Hey, this is Mr. Ward, and I apologize for the audio on these. I am using a school issued computer that is not that high quality. But I'm going to talk about problems from Chapter 10, Section 1 on circles. And I'm going to start with number 4. So, in number 4, you're given circle Q. That means that Q is the center of the circle. And you're also told that QT is perpendicular to RS. And you need to prove that TQ bisects angle RTS. Okay, so it would be very useful to be able to prove, here's my big hint, try to find a way to prove that RTP is congruent to STP. Because if you can do that, then you'll be able to prove that angle RTP and angle STP are congruent. Now, I encourage you to pause the video and try that on your own. You might find it useful to draw some auxiliary lines and so forth. I'm going to go ahead and start doing a proof for this. Okay, assuming you've paused, here's what I'm going to do. I'm going to start by drawing RQ and SQ. Okay, so I'm going to draw SQ as well. Those were terrible lines, but hopefully you get the basic idea. I think I want to use a different color for that. And use red. Okay, so RQ and SQ. Now those are radii, so they are congruent. Okay, we also know that QT bisects RS. So we know that this is a right angle. Okay, those are both right angles. Now, the next thing we know is that QP is itself. So I'm going to use, we'll use purple for that. So QP is itself. So we can use hypotenuse leg to prove that RPQ and SPQ are congruent. Now, once we've done that, then we'll be able to have established that angle TQS and TQR are congruent. So I'll go ahead and use yellow for that. See if this works. So I'm going to make, it's hard to see that. I don't like that color. We'll try black. Black will be clear.
Oh, thank you.
Okay, so that is congruent to that. All right, so that tells us, and that's just because of Kappa-Kadika. All right, now we're trying to prove that RTQ and STQ are congruent so that we can prove that TQ bisects angle RTS. And now we have everything we need. Because not only is QP itself, TQ is itself. Okay, and so now we can go ahead and extend this. This will be itself. We know RQ and SQ are congruent. We know that angle RQT and SQT are congruent. And we know QT is itself. So that also establishes finally that the triangles RQT and SQT are congruent. So I'm going to go ahead and establish that. So that means that if those are congruent, then these angles are congruent, and you'll be able to prove that TQ, these angles are congruent because these side triangles are congruent by Kappa-Kadika. Then you'll be able to prove that TQ bisects RTS because of that. Okay, I'm going to pause the video. Now for number 6, I'm going to repurpose the diagram on number 5 because it'll be a little easier to do if I do that than to try and just draw a circle with this. So we want to find the length of a chord that is 15 centimeters from the center of a triangle that has a radius of 17 centimeters. So I'm going to say that this chord, AB, is the chord we're considering, and we're saying that it is 15 centimeters, so 15 centimeters from that center, and that the radius is 17. So that's the first thing. Draw the diagram. Now, I'm going to encourage you to pause this and see if you can figure out what the length of that chord is based on the information that we have. And hopefully you paused. And if you did, I will now go ahead and talk about it. So since this is a right triangle with one leg that's 15 and a hypotenuse that's 17, then we can be very sure that this part of the segment is 8 because 8, 15, 17 is a Pythagorean triple. And you can demonstrate this with a Pythagorean theorem. And we also know that if we're getting the distance to AB, or to this chord from the center, then we've got a perpendicular bisector of the chord, which means that we've split the chord into 2 segments, and the chord is 8 and 8. So the answer is 16 centimeters. Like that. All right, number 7. We'll take a look at number 7. So we've been given PQRS as isosceles, an isosceles trapezoid with SR as parallel to PQ. My basic, and we're trying to conclude that circle P is congruent to circle Q. Well, I would encourage you to go back and remind yourself what some of the properties are of an isosceles trapezoid. Okay, and so hopefully you've paused this and you are now watching me talk this through. So we know that those are the parallel parts of the isosceles trapezoid. One of the properties of an isosceles trapezoid, though, is that the legs, being isosceles, are congruent. That means the radii of circle P and circle Q are congruent. And so since circles with the same radius are congruent, those circles are congruent. Now I'm going to stop the video at this point because I've gone on long enough, and I'll do another video about the remaining questions, perhaps 2 more videos about the remaining questions from Chapter 10, Section 1.